Electric generator, alternating current and direct current. Alternating current. Materials required: armature coil. Armature coil is a rectangular metal slab on which copper wire is coiled. Curve-shaped permanent magnets, 2 slip rings, brushes, galvanometer which shows the current. Place the 2 curve-shaped permanent magnets. Fix the armature coil between the magnets. Fit the 2 slip rings to the end of the armature coil. 2 carbon brushes attached in such a way that they press the slip rings to obtain current from the coil. Attach the galvanometer as shown in the video. The lines of force starting from North Pole to South Pole, also called magnetic flux. When the armature coil rotates, the lines of forces are cut and the magnetic field in the armature coil changed. According to the electromagnetic induction law, at electromagnetic induction, an induced current is generated in the coil. Consider initially the coil positioned in such a way that magnetic flux passes through it. When the coil is at rest in vertical position with side A of coil at top position and side B at bottom position, no current will be induced in it. Thus, current in the coil is 0 at this position. When the coil is rotated in clockwise direction, current will be induced in it and it flows from A to B. During the first quarter of rotation, the current increases from 0 to a maximum and reaches peak value when the coil is in horizontal position. If we continue the rotation of coil, current decreases during the second quarter of the rotation and once again becomes 0 when coil comes to vertical position with side B at top position and A at bottom position. During the second part of the rotation, current generated follows the same pattern as that in the first half, except that the direction of current is reversed. The current obtained by this process changes its direction alternatively for each half cycle. Electric generator with DC current. Materials required: armature coil, curve-shaped permanent magnets, 2 half slip rings, brushes, galvanometer. Place the 2 curve-shaped permanent magnets. Fix the armature coil between the magnets. The ends of the coil are connected to two half slip rings. Two carbon brushes attached in such a way that they press the half slip rings to obtain the current from the coil. Attach the galvanometer as shown in the video. When the coil is in the vertical position, the induced current generated during the first half rotation rises from 0 to maximum and then falls to 0 again. As the coil moves further from this position, the ends of the coil go to other slip rings. Hence, during the second half rotation, the current is reversed in the coil itself. The current generated in the second half rotation of the coil is identical with that during the first half of direct current.